everyone. Welcome back to Help I'm Teaching, a podcast for amateur educators. I'm your host, CP, and this podcast is for people who want to guide the teaching a topic they've learned in the past but maybe aren't so sure about now. Let's say you volunteered to teach elementary schoolers some basic science, like Newton's laws. You learned them when you were about their age, and probably can recite most of them, but you don't want to be caught unaware by a third grader and want to do better than just reciting a Wikipedia article. I'll provide you with fun analogies, common misconceptions, and extension questions that leave your students convinced you're an Oxford physicist. Today I want to talk about ecological succession. This is the process by which barren land slowly fills with life. This follows a predictable sequence beginning with the first arrivals, pioneer species, continues with some intermediate species, and ends in a climax community. I think it's an important topic to discuss early because we intuitively know a lot of the aspects of this process. However, we need a formal framework to put it all together. Ask students what kind of things grow on food that's left out. What would happen if you left spaghetti out, or, hypothetically, you left an entire field of spaghetti out for 1,000 years? That spaghetti field is full of nutrients, but how does that enter the ecosystem? It would smell bad at first, but you can reassure them that eventually you'd get something like grasslands and maybe later on even a forest through the magic of succession. There are two types of ecological succession. The first is known as primary ecological succession. It is when totally barren land, like a new island formed from magma in the ocean, is slowly colonized with soil, then plants, and then animal life. Secondary ecological succession is when a previously existing habitat is disturbed, like a forest burning down or grasslands being covered in a landslide. Either way, the process of ecological succession consists of several seers, S-E-R-E-S, singular seer. Seer is a term for the different plant communities in an area that change over time. Let's start by discussing primary succession on a newly formed island. First, the bare rocks on the island are eroded by the ocean and wind. The ocean and wind both contain tiny particles that rub up against the rocks again and again, eventually breaking down the rocks into tiny particles. This is known as physical weathering. If it helps, imagine polishing a rock with sandpaper. At first the rock is rough, but as you rub the rough sandpaper against it for a long time, it smooths and you can see small particles of the rock on the sandpaper and on the ground. Soon, the first pioneer species appear on the slightly eroded rock. We call the organisms of this seer pioneer species because they're the first life on the ground. Some of these are moss, algae, fungi, and bacteria that transform the compounds in the barren rock into forms that are more nutritionally available to other life. This process involves chemical reactions between rocks and substances secreted by the organism, and is called chemical weathering. This forms soil, and next, plants appear in the soil formed by weathering rock. Plants are natural agents of both chemical and physical weathering. Seeds germinating are capable of splitting rocks with their growing roots. These roots also acidify the areas around them to make nutrients in the rock more soluble and easier to uptake. In addition, as these plants die, they decompose to release their nutrients back into the ecosystem. Over time, plants in primary succession create more soil, which begets even more plants. A cool example of a pioneer species is the fireweed. This grass with striking purple flowers is known for being among the first colonizers of areas disturbed by human processes like mining or natural occurrences like wildfires. Fireweed is also edible, acts as an anti-inflammatory agent, and can be used to make jelly. In other videos, I've harped on the false weed/not weed dichotomy, and come on, how is a grass lawn more useful than this? After ample soil is formed from eroded rock, we can start to see the next seer and other kinds of species emerge. These are called intermediate species. Intermediate species consist of things like shrubs that can begin to take better advantage of the nutrient surplus. Around this point, you might start to see insects and small animals. Some plant families, like legumes, are known for their ability to fix atmospheric nitrogen into an organic form in the soil, making the soil even more nutritious than before. At some point, bigger animal life makes its way into the area and feeds on the pioneer and intermediate species. Animals generally don't show up very early because locomotion requires a lot of energy. Finally, after generations of intermediate species die off, they give way to climax species, which are species that can only prosper in the later series of ecological succession. These mainly feed on the intermediate species and tend to be bigger and are more showy than the previous stages. A forest is an example of a climax community. At the same time, predatory animals will arrive to prey on the herbivores of the intermediate seer. Because their defining feature is maintaining their ecological makeup indefinitely, climax communities are highly resistant to change by their natures. Until the next disturbance, the ecosystem will remain here. Many similar processes occur in secondary succession, with the caveat that soil doesn't need to be created from scratch. It also allows pioneer species to come from dormancy in the soil, like buried seeds. These buried seeds are referred to as the soil's seed bank. Because of this, secondary succession is a much shorter process than primary succession, 50 years to 1,000. Secondary succession often includes a lot of decomposition of the life disturbed by the catalyst event. For example, you may have heard that fallen logs are a great source of biodiversity. Moss, fungi, and associated bacteria and insects love to feed on and nest in the rotting wood, and will eventually break it down completely into nutrients that go right back into the ecosystem. Here are some common points of confusion. Pioneer species can come from the air and water all around us, even if we can't see them. There are also seeds in the soil during secondary succession. Often, certain kinds of seeds wait for an indication of a disturbing event like a wildfire before they germinate, specifically to increase chances of success. This is how a plot of empty soil can seemingly generate weeds out of nowhere. Moss is a very common pioneer species. Though you'll find them in the same place, moss is different from lichen. Lichen is a combination of fungi and algae living in symbiosis. Fungi provide structure for the algae to photosynthesize efficiently, and algae provide the fungi with nutrients to survive. This symbiosis allows it to grow pretty much anywhere there's moisture. Pioneer species, despite being the first ones on the scene, aren't necessarily better at surviving everywhere than the climax species. They have the advantage in the early stages because something like moss might be less energy expensive than a lavender bush, but at a certain point in the process, the environment has suitable nutrients to support that lavender bush. At that point, the energy-efficient ways of moss aren't really important, and what's more important is the ability to take advantage of pollinators to disperse yourself like lavender does with its distinctive scent. For a silly example, you're probably better off bringing your computer, notebook, and stationery to a lecture than an entire camping set with rations, because school hopefully isn't an environment where you're focused on making sure you don't die of exposure, thirst, or hunger. Of course, the moss never really goes away. You'll still see it on rocks or trees. You just won't find vast fields of moss outcompeting trees in a climax community. We're never actually sure if succession has a definite endpoint. While climax communities are resistant to change, climate change has created frequent disturbances in so many areas that even these climax communities can be uprooted by one bout of bad weather. This is just another reason why climate change negatively affects the environment. If species can't stay in an area long enough to prosper, eventually most habitats will be dominated by only organisms that have the traits of pioneer species. Pioneer species tend to be pretty simple, so if you love your mangoes and marigolds, you should probably do your part to stop the spread of climate change. Here, as usual, are some questions your curious ones might ask. Can we observe ecological succession in real time? Yes and no. Primary succession can take hundreds to thousands of years, and while you may be able to see slight transitions in communities, you generally won't see it occur from start to finish. Secondary succession, on the other hand, is more observable as the ecosystem isn't starting from scratch. These can take decades though, so still pretty long. In some cases, we can observe different stages of succession in the same environment if the agent of disturbance is something like a glacier thawing. The areas thawed earliest by the glacier will be at a later stage in succession than the more recently thawed areas. And as mentioned, you can see pioneer species at work just by tilling a patch of soil and letting it sit for a few weeks. It's obvious that in secondary succession, organisms in adjacent ecosystems can just move in, but how can intermediate and climax communities arrive on bare islands during primary succession? A lot of different ways, and this is why seed dispersal is so important. You would get plants using what's known as drift seeds, which is when seeds are designed to go wherever the current carries them. Hopefully this is an island. Coconuts are a great example of this. Seeds of certain plants can also be dispersed up to 100 miles away by traveling on gusts of wind. Then the birds can show up too, dispersing more seeds that might be in their digestive tracts or on their feathers. These seeds will simply die if the area isn't at the correct sear. As for land-dwelling animals, it's either insane luck like a current carrying a population of iguanas floating on a log to a new island, or humans accidentally introducing them as stowaways on their ships. But the difficulty that some organisms have in moving to new areas is part of what creates the beautiful biodiversity we see around us. As multiple populations of organisms stay in their own areas for a longer time, they become adapted to that area and eventually become separate new species. This is known as speciation. How and why do people stop ecological succession without getting rid of the entire habitat? Okay, no one's probably going to ask that one verbatim, but what I'm referring to in this case is salting the earth to stop plant life from growing. This was used in war to deny enemies cropland, and not only kills existing plant life, but makes it difficult to grow anything there until all the salt can be leached out. Excessive salt is one reason why high applications of manure can damage crops. And if nothing can grow there, no succession can take place and the land will remain barren. Speaking of humans, are humans climax species? A human, no matter how smart, can't survive on bare rock. We require lots and lots of nutrients to even create a food web necessary to support our needs as apex predators. And our large brains use way too much energy to survive off photosynthesis like a pioneer species would. So whenever you hear the word pioneer used to describe people, just know that it's really the work of thousands of years of interconnected life cycles, and we're taking all the credit for that. However, it's important to note that one trait of a climax community is the ability to sustain itself indefinitely, and only time will tell if humans are capable of keeping Earth alive. How does succession work underwater? A lot of things that happen on Earth happen underwater too, like volcanic eruptions and submarine rock slides. An underwater area slowly has sediments and organic matter deposited into it. Phytoplankton, small photosynthetic organisms, act as the pioneer species. As they grow, reproduce, and die, they bring nutrients into the ecosystem that small aquatic plants can take advantage of. These plants lay the nutrient groundwork for larger plants and organisms like small crustaceans, and finally the fish arrive. You can see the parallels to terrestrial succession pretty clearly. This can most easily be observed in the creation of artificial reefs, which is when man-made structures are left in the ocean for nature to reclaim. You'll see green algae growing on the structures, then seagrasses, small fish, and barnacles, and eventually larger predators. Where does the energy come from in succession? In 99.9% of cases, it comes from the sun, though it can come from energy in underwater thermal vents or other naturally occurring chemical reactions. The ecosystems of these types of succession look radically different to anything on land because there's no green from photosynthesis. Often they rely on oxidizing compounds to gain energy. That's why pioneer species are all autotrophs, or organisms that can synthesize their own food, and you'll never see, say, lions colonizing a bare patch of rock first. On that note, this is a great way to introduce the idea of trophic levels. The reason predators show up later in succession is because they require more energy. But what does that mean? Think of how a plant makes energy from the sun. In that case, it receives close to 100% of the energy. But when the plant is eaten by an animal, that animal only receives about 10% of that energy from the sun. This is because 90% was given off as heat or turned into inedible parts of the plant. And when that first animal is eaten, the same 10% is true, meaning only 1% of the original sun energy is gained. We call these tiers trophic levels, where pioneer species occupy the first trophic level, and succeeding organisms occupy increasingly higher tiers where they need to consume more and more to get the same energy. For organisms on the fifth trophic level, like predators, they need to consume 10,000 times more calories than the pioneers. Being a predator doesn't seem so great now, does it? To close, you could ask them about areas like disused corners of the school or overgrown areas at parks and lots. What signs of life did they see? What do they think would happen if the areas remained unused? Or from another angle, why do post-apocalyptic movies always show buildings and streets overgrown with vines and maybe even wildlife? That's ecological succession at work. From a certain perspective, even mold growing on food could be considered a pioneer species, fearlessly colonizing your leftover plate of lasagna. We're constantly battling encroaching pioneer species to maintain our human habitats, but when we're not around to do so, life finds a way. And that's Help I'm Teaching. I'm your host CP, and I hope you learned a little something from this episode you can pass on to your students. Don't forget to give us a 5-star review. It helps get this podcast to people who really need it. See you next time.